Hey folks, Mr. Reitzel here, bringing you a lesson on standard atomic notation and new and improved Bohr diagrams. Unfortunately, I can't be there today, so I'm going to have to give you this lesson via YouTube, courtesy of the internet. And no, we're not talking about the interneting on the inside of your bathing suit, we're talking about the World Wide Web. Anyway, to get things started, standard atomic notation. Now, standard atomic notation is just another way that chemists represent elements. So how they represent it is they give three pieces of information. The first piece is the chemical symbol. So O for oxygen, B for boron, K for potassium, etc. Then on the bottom we give the atomic number. And this represents the number of protons that that atom has. And lastly we give the mass number, which is the number of protons and neutrons, because as we all know, the mass of an atom comes from its protons and neutrons, not from its electrons. Those have very, very, very little mass. A minute amount of mass makes very little difference. Well, let's look at an example. Let's say sodium. So what's the symbol for sodium? Daniel, what do you think? What's the symbol for sodium? Are you looking around the class thinking, is he watching me? And the answer is maybe. Maybe I am. Anyway, Daniel, what is it? Na for sodium? You are 100% correct. So sodium, Na. And how many protons are in a sodium atom? What's its atomic number? What's that? Owen at the back. Yes, you are correct. There is 11 protons. And what is the total mass of a sodium atom? I.e., how many protons and neutrons does it have together? Yes, you are correct. It is 23. And notice how we have to round this to the nearest whole number. So we're going to round this to the nearest whole number. So I'll give you a second to get this example written down, and then we'll move on to some practice where you can practice on your own. So if we want to pause the video, get that information, then we'll continue. Alright, and continuing on. Oh, another tip, I forgot about this, to help us remember what goes on the top, what goes on the bottom. Well, it's always the big number on the top and the small number on the bottom. So you can think biggie over smalls. Get it? I thought it was pretty cool. I know it's kind of opposite of what you see on the periodic table where they give the atomic number first, but some things in life just get upside down. Anyway, let's work on some practice. So again, pause the video, spend a couple minutes doing the standard atomic notation for these three examples. Alright, and we'll take them up. So looking at carbon, the symbol for carbon is C. It has 6 protons, so the number on the bottom is 6, and its total mass is 12. Looking at uranium, the symbol is U. It has 92 protons, and it has a total mass of 238. That means it's got quite a few neutrons as well. And the last one, looking at chlorine, symbol Cl. It has 17 protons and 35 total mass. So that's 35 protons and neutrons all added up together. And notice how in this case we had to round down to 35. Alright, and that brings us to the end of standard atomic notation. The other new thing we're going to do today, well, it's not really new, is we're going to look at Bohr diagrams, but now they're enhanced. And you might be asking yourself, Mr. Reitzel, how are these enhanced? Well, what we're going to do is we're going to get rid of the symbol in the middle, and we're going to replace it with the number of protons that that atom has, as well as the number of neutrons. I know, I'm pretty amazed by it too. So, where does this information come from, the number of protons and number of neutrons? Well, hopefully, I gave away the answer at the end. Potassium has 20 neutrons. How did I get there? Let's find out. Anyway, so the number of protons that a potassium atom has, well, that's pretty straightforward. We can just look directly at the periodic table and know that the atomic number of potassium is 19, and that just means that it has 19 protons. The number of neutrons, that's a little trickier. Well, we know that the entire mass of the atom is approximately 39. Right? And what makes up that mass? Well, it's not the electrons, because they have pretty much no mass. It's the protons and the neutrons. So, in this case, we have the protons and the neutrons adding up to 39. 19 of those were protons, so whatever's left over has to be the number of neutrons. So in this case, 39 minus 19 is 20, so that's why potassium has 20 neutrons. Well, let's actually look at an example of a Bohr diagram. Again, we're going to keep going with potassium. So, how many electrons does it have? What's that? Yes? Aaron, what do you think? 19? Why 19? Because that's the number of protons it has, and because one's positive charge and the other's a negative charge, there needs to be 19 of each for it to balance out. You'd be 100% correct. Well done, Aaron. Well done. Anyway, number of electrons is 19, protons is 19, and as we calculated earlier, the number of neutrons was 20. How does this look in the Bohr diagram? Well, like I said, instead of putting the symbol in the middle, you put the number of protons and the number of neutrons. So let's do that. Ta-da! So P is 19 for protons and N is 20 for neutrons. And then we can just fill in the rings with electrons like we normally would. So in this case we can fit 2 in the middle ring, 8 more in the second ring, 8 more in the third ring, and I think we need to add 1 more to this. Yep, to bring it up to 19. Anyway, take a minute to get this example written down in your notes, and then we'll move on to one more practice. Okay, moving on to one more practice. Chlorine. So again, pause the video, try to do it on your own, and then we'll take it up. Okay, now it's time to take it up. So chlorine. Well, let's look at the number of protons and electrons. How many is that going to be? Anybody? Aaron, I'm going back to you again. What do you think? 17 and 17? You are on today. Yes, you are correct. There are 17 protons and 17 electrons. And since the total atomic mass in this case is 35, we know that that 35 is composed of protons and neutrons. So again, 17 of those are protons, so whatever's left over has to be the number of neutrons. So again, we go 35 minus 17, and that tells us there's 18 neutrons. So, like before, we'll put that in the middle, the number of protons and the number of neutrons, and then add the electrons to the outside. And here we have up to 17. Notice how it needs 1 more electron to fill its outer ring. That's why it forms a negative ion, because again, it wants to gain an electron. Now, I have a question for you. We took away the symbol. Why don't we need the symbol anymore? Is there any other information in this diagram that tells us what element it is? Anybody? Let's go, Kevin in the back. What do you think? You think that we don't need the symbol because we already know the number of protons and each element has a unique amount of protons? You'd be correct. So knowing that there's 17 protons also tells you that it's chlorine. Alright, one more example, oxygen. So again, pause the video, give it a shot on your own, and we'll take it up. Alright, let's take this last one up. Almost done. So we have 8 electrons, 8 protons, and in this case the total mass is 16. So 8 of those are protons, that means the other 8 have to be neutrons. In this case, the number of protons and neutrons is the same. Coincidental? Yes. Yes, it is actually. So, we'll put those numbers in the middle. Make sure we fill those rings with the 8 electrons. And there you have the new and improved Bohr diagram for oxygen. Thank you very much for taking part in my webcast today. I hope you all have a fantastic morning and a wonderful Thursday and a wonderful long weekend. Good luck with your studying for the exam, and don't forget that your element assignment is due Monday.